What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we start a new topic looking at arithmetic sequences. Today we are just going to focus on an introduction to an arithmetic sequence, determining what one is, and taking a look at some of the key components for an arithmetic sequence. So let's jump right into a definition here. An arithmetic sequence is going to be a sequence we know that is a set of ordered terms created by adding a value from one term to the next. So there's going to be a common difference in between the terms. So the amount from one term to the next term will be constant all the way through the entire sequence. So it's an addition or potentially a subtraction, as subtraction is an addition of a negative number. So let's jump right to some examples. It says in problem number one, determine if the given sequence is arithmetic. And so we want to identify if the difference between the values is the same, if it's constant. And so we could use the calculator if we need to. I can take a look at my second term here. Let's call this A2, and I can subtract my first term. So I can do A2 minus A1. And so 5 minus 2. And I would see that that number is 3. I can do the same thing with A3 minus A2. So my third term here would be 8 minus 5. That difference is 3. Do the same thing with the fourth term. So A4 minus A3. 11 minus 8, and we would see that that difference is also 3. So we could say that, yes, this is an arithmetic sequence. And again, because when we take a look at the terms, we can see that the difference between each of them is 3. So we use the calculator there. You wouldn't necessarily need to use the calculator. If you could do that mentally, we're just finding that difference. So let's go ahead and take a look at 1b, and I'll write the work out here as we go along. You can do this entirely in the calculator, but again, what we want to find is what is the difference between the terms. So I'm going to take the second term, A2, and subtract the first term. Now if I put this in a fraction, I'm going to go ahead and do that to make sure all of these differences are exact. I can see that the difference between the first and the second term is 1/3. Now this one may be a little bit more challenging to do mentally because we're dealing with fractions. The first one, you guys could probably quickly see the difference between each term is 3. Here we might actually need to do some computations. And as I take the difference between term 3 and term 2, so the third term was 4/3 and the second term was 5/6, I'm going to see the difference between those two is 1/2. So the difference between term 2 and term 1 is not the same as the difference between term 3 and term 2. So this is not arithmetic. It is a sequence of some kind. These fractions or these numbers are ordered in a specific manner, but it's not arithmetic. Let's take a look at 1c. See if you can determine if 1c is arithmetic or not. So hopefully you got a chance to take a look and take a look at 1c and view the terms. So again, what we want to do here is find the difference between the terms. So from the second term, -2, to the first term would be a difference of -3. Now, you could leave that as a positive difference if you wanted to show kind of the distance on the number line. That's okay. We just need to be consistent here. So I'm going to subtract each of these. I'm going to subtract the higher term from the lower term in terms of numbers. So -5 minus -2 would be a -3. If I look at the fourth term subtracted by the third term, so our fourth term is 8, or -8 minus -5 would be -3. And you could keep going here. We could do the fifth term minus the fourth term. So -11 minus -8 would be -3. And finally, the sixth term minus the fifth term, -14 minus -8 would be -3. This is arithmetic. So what we have to do there is see if there's a common difference. The value between each term is the same as we move through that sequence. And in cases of 1a and c, they're arithmetic. In problem number 2, it says write the first 5 terms of the arithmetic sequence given the first term is A1 and the common difference D. So they're going to give us the common difference, the amount between each term here. So what we know is the first term for 2A, first term is 12. So term 1 would be 12. If I want to find what the next term was, I would apply the common difference. I would subtract 4 from 12. And I would get the second term is 8. To subtract 4 again from 8, I would get the third term is 4. If I subtract 4 again, I would get the fourth term is 0. And I could go on to negative 4. And we'll put this dot, 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 meaning that this sequence can continue. So my terms, my first 5 terms would be 12, 8, 4, 0, and negative 4. In B, we're starting with the term 1/2. And the difference is 1/3. So we want to be exact here. Again, we want to avoid, there is no rounding in sequences. We want to give the exact number. So we are going to deal with the fractions. It gave us the first term as 1/2. The difference between these is a positive 1/3. So I'm going to go ahead and add 1/3. And if I do this in the calculator, you could do this mentally if you can find common denominators quickly. But if we want to use the calculator, that's okay. What I would do here is hit math and then the fraction key to get 5/6. So the second term is 1/2 plus 1/3. Now I'm going to take the second term, 5/6, and add 1/3. And I'm going to convert that again to a fraction, so 7/6 would be my third term. I would add 1/3 again to get my fourth term, which would be 1.5, also known as 3/2. And then add 1/3 one more time to get my fifth term here. If I convert that into a fraction, that would be 11/6. And we could carry this pattern on as needed. See if you can pause the video at this point and come up with the first 5 terms for 2C, starting with -2 with a difference of 3. Hopefully you got a chance to find each of these values. So the common difference is a positive 3, starting with -2. We would add 3, so this should go -2 plus 3 would be 1, plus 3 would be 4, plus 3 would be 7, and plus 3 would be 10. So in this case, we are starting with a number and adding the same value over until we get our select number of terms. In this case, we wanted to find 5. So here we have an introduction to arithmetic sequences, a sequence found by adding the same value to each successive term. As always, thank you guys for tuning in, and I'll see you.